If we remember from class, we have 3 classes of levers. We call them first, second, and third. We name them according to what is in the middle of the lever. So we have 3 components to each of them. We have the force, we have the axis, and we have the resistance. The force is exerted by the muscle on the bone, so we label that at the muscle insertion. Again, that's the force that's generated by the muscle. The axis is the joint or the point that the lever rotates around. And then our resistance is what we're attempting to move. So this is something that has mass. This could be the weight of the extremity. This could be some kind of resistance or a weight that's in your hand, or this could simply be gravity. When we determine what class a lever is, we are looking at which of these components of the lever is located in the middle. Okay, so we have our 3 levers down here at the bottom. We have first class, second class, and third class. In the middle of the first class lever is our axis. Our force and our resistance then are located on the ends. It's important to remember we are only concerned with what's in the middle. The 2 forces that are on the ends are interchangeable in every single one of the levers. So in the first class, our axis is in the middle. In the second class, our resistance will be located in the middle. And our axis and our force located on the ends. Again, these are interchangeable. And then in our third class lever, our force is in the middle, while the axis and resistance are on the ends. And again, these 2 are interchangeable. So again, when we look at our classes, we are only looking at what's in the middle. So in a first class lever, our axis is in the middle. In a second class lever, our resistance is in the middle. And in a third class, the force is in the middle. So you can just remember, again, which is in the middle. The 2 things that are on either end are interchangeable. Again, our force is labeled where the muscle inserts on the bone. The axis is labeled as the joint, and the resistance is what we're trying to move, be it the weight of the extremity, gravity, or some kind of external weight. In this image, we'll start with the bicep. So again, we need to label our axis, which is the joint, our force, which is the muscle, and then our resistance, which is the mass we're trying to move. So on this image, our axis, if we're talking about the bicep, our axis is going to be our elbow joint, right through here. Our bicep inserts right here, so that would be where our force is exerted, and then our resistance in this situation is going to be the mass of the arm, or down at the hand. So if we were to put these 3 things on a straight line, can we have our resistance on one end, force in the middle, and then our axis. Coming back to our 3 classes of levers, at the top we have the axis in the middle on first class, resistance in the middle on second class, force in the middle on third class. So because we have our force in the middle, this would be classified as a third class lever. So if we look over at the other side, this time looking at the tricep, again we have to label our axis, which is the joint, our force, which is the muscle insertion, and our resistance, which is the mass that we're trying to move. If we're looking at the tricep, our axis again is going to be the joint. Okay, looking at the elbow joint. Our tricep inserts down here on the back of the olecranon in the elbow. And then our resistance again would be the weight of the arm. So if we imagine that our arm was a little bit straighter, okay, our olecranon sticks back a little bit behind. So our force inserts here, our axis, and then our resistance would be down in the forearm. So if we put these on a straight line, we would have resistance, axis, and then force. Again, if we look back over at the other side, our axis is in the middle on a first class lever. Here we see our axis is in the middle, so this would be a first class lever. The next thing that we need to discuss is force arms and resistance arms. Now, a force arm is the distance between the axis and where the force is exerted. So the distance between the joint and the muscle insertion. The resistance arm, similarly, is the difference between the axis and the resistance. So the joint and where the force is being applied. Force meaning the resistance force. So the mass, gravity, whatever that is in that situation. So if we look at some examples of lever arms, beginning here, so we'll say our axis is on this end. We'll put our force in the middle and our resistance down here. So again, excuse me, when we have the force in the middle, we would be looking at a third class lever. Okay. When we talk about the force arm, again, it's the distance between the axis and the force. So this would be our force arm. When we talk about the resistance arm, it's the distance between the axis and the resistance. So the axis and the resistance. Now these are given as distances. So this could be listed as 10 inches and the force arm could be listed as 5 inches. It's important to note that we can have some overlap between the two. Okay, we have this area where we have overlap between the force and resistance arm, and that is a normal thing. We'll see that with both our second and third class levers. So when we talk about force and resistance arms, there is a correlation between the length of both the force arm and the resistance arm and the amount of force that it will take to move a resistance that we're dealing with. So if we have a lever here, starting with our axis, and we are applying our force here, we'll say that our resistance is right about here and it's 10 pounds. We're going to compare that to another lever with our axis here, exerting the force down here, and our 10 pounds stays in the same position. In this case, our resistance arms will be the same, so they're not changing in length. Our force arms, however, have changed. Okay, so in our top example, we have a shorter force arm. In our bottom example, we have a longer force arm. Our forces are the same on both of them. Okay, now think for a minute about which of those would require more force to move that same 10 pounds. It's going to be the top one. Okay, we have an inverse relationship between the force that's required to move a resistance and the length of the force arm. So if we have a longer force arm, we need less force to move the same resistance. Okay, so increasing the length of the force arm means we need less force to move the same resistance. If we were to decrease the length of the force arm, that would mean that we need to increase the force that we need to move the same resistance. Okay, so force arms have an inverse relationship with force. Now we're going to look at resistance arms. So again, we have our axis. And we have our lever. Two different lengths. Okay. On this one, we're going to apply our 10 pounds of resistance there, and on our bottom one, we'll apply it out here. Okay. We will say that our force is being exerted at the same point on both of them. So we'll say that our force is occurring right here. Okay. If we look at these two, again, we're looking at the resistance arm here. which of these two will require more force to move that same 10 pounds? Okay, it's going to be that bottom one. So when we deal with resistance arms, okay, when we have an increase in length of the resistance arm, we also have an increase in the force needed to move that same resistance. Okay, so with resistance arms again, we have a relationship where if we have an increase in the length, we'll also have an increase in the force needed. Similarly, if we have a decrease in the length of the resistance arm, we have a decrease in the force needed. So if we think of this in terms of a bicep curl, if you're doing a bicep curl and you have the weight in your hand and you exert force enough to cause the motion, if you were then to move that weight up closer to your elbow, that motion would become easier. So to recap one more time, our force arms have an inverse relationship. So if we increase the length of the force arm, we decrease the force needed to move the same resistance. If we decrease the length of the force arm, we increase the force that's needed to move the same resistance. When we're dealing with resistance arms, if we increase the length of the resistance arm, we increase the force needed to move the same resistance. If we decrease the length of the resistance arm, we decrease the force that's needed to move the same resistance. When we're looking at these force comparisons, remember that's always to move the same amount of resistance. So if we start with 10 pounds, we have to consider 10 pounds the other way. Okay, so always make sure that those forces stay consistent. So we can use this information to determine which muscles would be more efficient in certain situations. So for example, if we have a joint, we won't even decide which joint this is per se, and we have one muscle that goes from here to here, and we have another muscle that goes from here to here. Okay, our resistance arm on this muscle, we'll say that our resistance is out here. Our resistance arm would be from here to here, and those resistance arms are going to be consistent. That's not going to change. Okay. The force arm on this top picture would be from here to here, and the force arm on our second picture would be from here to here. So this picture has a longer force arm. This picture has a shorter force arm. Okay. So by that example, this picture would require less force, meaning that muscle would be more efficient at moving that same resistance. Over here, since we have a shorter force arm, we would require more force, and that muscle would be less efficient. So looking at a similar situation, if we had the same muscle coming down, so we had the same force arm on both of these muscles. But let's say that we took that resistance and we placed it here on this muscle, so this would be our resistance arm, and we placed it here on this one, so this would be our resistance arm. Okay. This muscle, the first muscle, has a longer resistance arm, meaning that it will require more force to move the same amount of resistance, meaning it's less efficient. Over here we have a shorter resistance arm, meaning we would require less force, meaning that the muscle is going to be more efficient. So we can use the force arm and the resistance arm to determine the effectiveness of a muscle, which could produce more force in a given situation, and which one really is going to function in a situation. Now, it's important to keep in mind that force arm and resistance arm isn't the only thing that's going to determine the amount of force a muscle can output. We could also look at the cross-sectional area as well as the length of the muscle, but this is just one more piece to the puzzle.